Hello, everybody. So today we are talking about definitions. Okay, so definitions are extremely important in math. It is important that you learn a definition, that you learn it exactly, okay? Often if you change one word in a definition, you will change all the mathematics that is built off that definition. So an example of that would be if I said, if I made the definition, a circle is the set of all points in a plane equidistant from a center point. Then what we get then is we have a center point, and it's in a plane, so it's in a flat surface, and I take this, and there's a circle. But if I leave the words in a plane out, okay, I have the set of all points equidistant from a center point, I no longer have a circle, okay? I now have a sphere, okay? Here's a sphere. Whoops, don't want that. That's the set of all points in space that are equidistant from a center point. Okay, so there's a difference between the two. Okay, so now, what's a counterexample? That's really important to know what a counterexample is. Okay, given a statement, if P, then Q, a counterexample is if P, then not Q. Okay, so an example of that would be something like, if it is cold, we will not go outside. Okay, so the P part of this statement is it is cold. Okay, I should have a then written in here. Okay, then the then part is that part. Okay, so let's just go ahead and put the then right here. Now, a counterexample to that would be it's really cold and we went outside for some reason. Okay, that would be a counterexample. So, find a counterexample to the statement, if x squared equals 9, then x is 3. Well, you probably remember that if I square root this, the square root of 9 is plus or minus 3. So if I said, okay, what about x equals negative 3? Then this is true. X squared would be 9, because negative 3 times negative 3 is 9. But x is not 3. So there's my counterexample. Okay? All right. So, find a counterexample to the statement, if the Red Sox score 5 runs, then they will win. Okay, a counterexample would be the Red Sox play the A's and the score was Boston 5 and Oakland 6. Okay? So even though Boston, the Red Sox, scored 5 runs, they still lost because Oakland scored more than them. Okay. So a definition of an acute angle. Okay, the word acute actually means sharp. You can have an acute pain. That means it's something that's sharp. It really hurts really bad, really, really sharp feeling, okay? So an acute angle is a sharp angle. It's an angle that is less than 90 degrees. Okay, so acute angles look like this. There's an acute angle. Okay, there's a really acute angle right there. Okay, so that's an acute angle, very sharp. Now, it could be as much as just like that. Maybe that's 89 degrees. Could be 89.999 degrees. Okay, that would still be an acute angle. Now, an obtuse angle is, the word obtuse means dull, by the way, an angle that is more than 90 degrees, but less than 180 degrees. Okay, so an obtuse angle would look something like this. That's a dull angle right there, okay? You get poked with this, that's going to hurt. You get poked with this, that's not going to hurt. Okay? So that's an obtuse angle. It's dull. It's more than 90. It's less than 180. Okay, a right angle. A right angle is an angle that is exactly equal to 90 degrees. Okay, so a right angle would look like this. Okay, there's a right angle, and what we always do is we always put a little box in the corner like that to show that that's a 90-degree angle and it's not just, 89.9 or something like that. Put a little square corner. Didn't do a very good job of that right there, so let's redo it. There we go. That tells me that's a 90-degree angle. Okay, now the other thing that you can have, and I didn't put on here, so we'll go ahead and write it on, is a straight angle. Okay, a straight angle is an angle that is exactly 180 degrees. Okay, and a straight angle looks just like a line, like this. There's a straight angle. Okay? So those are my different kinds of angles: straight, right, obtuse, and acute. All right, now we have something called vertical angles. Okay? So vertical angles are formed. Oops, this should be a line. Okay. And we'll have another line like that. Okay. When we have two lines that intersect, we have two pairs of vertical angles that are formed. Okay. So the vertical angles are the angles that are not adjacent to each other. Okay. So we would say vertical angles are angles formed by two intersecting lines that do not share a side. Okay, so if I have this situation here, and I go ahead and I put these numbers in here, okay, angle 1 and angle 3 are vertical, and angle 2 and angle 4 are vertical. Okay? Now, if you look here, and you look really carefully, let's kind of exaggerate this a little bit. If I take this and I kind of do this like this. Okay. There we go. All right. That's a little better. Now that I've exaggerated a little bit, it's pretty obvious if you look at this that angle 1 and angle 3 are equal to each other, and angle 2 and angle 4 are also equal to each other. Okay, and so we have a theorem, and that theorem, and you'll want to know this: vertical angles are always equal. Okay, vertical angles are always equal. So that tells me these two angles are equal, and that also tells me that these two angles are equal. We'll go into that a little bit more later. Okay, what is a linear pair? A linear pair looks like this. I got a line, and then I've got a ray. Oops. Sorry about that. This is a linear pair. Okay. Of course, pair means two. All right, and linear means line. So literally a linear pair is two angles that form a line. Okay, so here I have two angles, angle 1 and angle 2. They share a side, okay? And you can see that the two angles together, they form this line right here. Okay. Now, since this is a straight angle right here, it's always equal to 180 degrees, which means that linear pairs always add up to 180 degrees. Okay, now there's other angles that are not linear pairs that add up to 180 degrees. For example, I could have this angle and say that that's 45 degrees, and I could have this angle. Whoops, that's not right. Right there, this angle is 135 degrees. Those two angles add up to 180 degrees, but they don't form a line, okay? And so they're not a linear pair, okay? However, they are something else that we'll talk about in a minute. So, complementary angles. Complementary angles are any two angles that add up to 90 degrees. Okay, any two angles, no matter where they are, I got a 1 degree angle, I got an 89-degree angle, that adds up to 90, they're complementary. Okay. They don't have to touch each other. They don't even have to be in the same plane. Just any two angles that add up to 90 degrees. Now, supplementary angles is another one you're going to want to really know this one. Supplementary angles are any two angles that add up to 180 degrees. Okay, so these two angles here would be supplementary. All right, they're not a linear pair, but they're supplementary. These two angles right here, they are not only supplementary, but they are also a linear pair because they form a line, they share a side. Okay, so linear pair is more restrictive than supplementary is. Okay, so here we go. We got a little assignment for you to go with this. I will talk to you guys in class. Have a great evening.